All right, so we've got a 15-year mortgage making payments every month for 15 years. That's 180 payments that you will make until the loan is fully paid off. So that's our T, 180. Our rate R is going to be 4.67% over 12. So it's 0.0467 over 12. So it's 0.003891666 forever. Or you could round it up to 6667 or whatever. So you guys could use that big long decimal if you want. I'm probably going to try to calculate this more accurately. So I'll do 1 plus this over 12. And we got to use the correct formula, which is the amount borrowed equals the calculation. Amount borrowed is the same thing as amount we can borrow. So we go monthly payment, and then it's times 1 plus r to the power, 1 plus r to the power of t, subtract 1 over r times 1 plus r to the power of t. Okay, so 1 plus r times 1 plus r. I'm going to put it in exactly, so I'm going to go 0.0467 over 12. And a really quick note on the calculation right there is that we can't add these because we're doing PEMDAS, and when you do PEMDAS, parenthesis, exponent, multiply, divide, add, subtract, you want to divide this by 12 and then add the 1 on. You don't want to be adding 1 and then dividing by 12. So if you write this out like that, the calculator understands PEMDAS. It will do the division and then it will add. So divide and then add, right? But what you cannot do is go 1 point, add them right off the back. Go 1.0 467 divided by 12, because you'll get this. You'll get like 0.08725. That's like 8.7%. That's totally wrong, because that's different than 1 plus 0.0467 over 12, which would be 1.00389. And that's this is the interest rate we want, the 0.389%, right? Because that's our monthly interest rate. That's like 0.389% approximately, right? Approximate interest rate per month is 0.389%. So that's what we want. 1 point that is our 1 plus R. That makes sense? So, okay, so that's an important thing. So we got 1 plus R, and then we subtract 1. And so that would be on the top. And then it's all over. The bottom is R times 1 plus R to the power T. So R would be, again, 0.0467 over 12 times 1 plus 0.0467 over 12 to the power, forgot the power of T in the top here as well. It should be 180, power 180, right? So that's how our formula is set up. In the calculator, if I want to get that top correct, I'm going to go 1275 star, or multiplied by, and then I'll do 2 parentheses. So I'll do parenthesis because I want to contain the negative 1. So I go parenthesis and then parenthesis, and then 1 plus 0.0467 over 12 divided by 12 to the power of 180, and then subtract 1 and then close parenthesis. So that would be the top in the calculator. And you could do divide and then put the bottom in parenthesis if you want to, or you could just do the bottom as one line. So the bottom would be, we can do parentheses, 0.0467 over 12 star, and then multiply that by 1 point plus to the power of 180. So a little hat sign is your exponent. Okay, so that's the top, that's the bottom. You can get both of these numbers and then divide. Or if you want to do it as a one line, which is kind of risky, you could, type all this out and then go hit, divide, and then put parentheses around the entire bottom, right? Because you've got to get all of the bottom calculated and then divide. So the last thing the calculator does is it divides. So what the calculator would do in this case is we go left from right, calculate all this, And then it would go, oh, I've got all of this in a parenthesis. So it calculates all of this to one number, and the last thing it does is divide. So if you want to be risky, you could do all of it in one line. That's fine. I'll just probably break it up into two just to be a little bit more careful. But 1275 times parenthesis. And we'll all do this and see if we get the same thing. So I'm getting 1290.3287776. I'll just write out the whole thing for fun. But I'm actually gonna use my arrows. I'm gonna use the calculator's exact numbers here anyway to divide, so it's going to be perfectly accurate anyway. And then the bottom parenthesis. So I'm not going to do the red dividing thing. I'm just going to type in the top, then type the bottom. So I'm going to do the bottom now. Times parenthesis 1. And I guess one thing that's popping up is on my calculator, instead of this slash, I'm getting a divide by sign, so that's fine. Your calculator might have a slash for divide or divide by sign, same thing, no problem. Plus 0.0467 over 12, and then to the power of 180. So on the bottom it looks like I've got that. So your bottom should look like this, 7830121. Now, I'm not going to type those out and divide, although you could. Just to be beautifully accurate, I'm going to use my arrow keys here. I'm going to just take the top. I'm going to go up. I'm going to take that. I'm going to press enter. Alright, and then I'm going to take my arrow keys again. I'm going to go up. Oh, sorry. And what I meant to do was put in a divide then. So take that and then hit divide. Then arrow. I'm going to take that number. I'm going to hit enter. So now I got that divided by that. Hit enter and I get 164,790. Right. So and I just round that to the nearest dollar. $164,790. Or if you're asked to round to the nearest thousand, everybody round that to the nearest thousand. Take your time. So this is rounded to the nearest dollar, or we could round to the nearest thousand. We're all good at rounding, so we can round to whatever we would like, right? Round to the nearest thousand, 165,000, right? Which in real life, which one should we use in real life? Round to the nearest dollar? Or how about the nearest cent? You want the nearest cent, the nearest dollar, or the nearest thousand? And the real life situation is you're figured out how much you can borrow to buy a house. What would you use in everyday language? Would you use the nearest cent, the nearest dollar, or the nearest thousand? Nearest thousand, right? You're walking down the street and you're chatting with your spouse and say, it looks like we can afford 165,000. You wouldn't say, oh, it looks like we could afford $164,790.40. Because like the interest rate might change overnight, then that's going to put that off a little bit, isn't it? So, or you may not want to borrow the amount you can. You might want to borrow anyway. The point is, yeah, everyday speak, I would say 165,000 would be a nice thing. Alrighty, that work? Alright, so so everybody on that note of, like, should we use the big long decimal or should we do it exactly? I mean, if you're taking one of my tests, like, it doesn't matter, you're going to get it right either way. It'd be kind of nice to use this skill of actually typing it out. It's more accurate, and it's kind of what you would use if you were actually using this in Microsoft Excel spreadsheets or Google Sheets or some other type of spreadsheet software. The only difference is you would just put an equal sign in front of it, as you're going to see when we do our rent mortgage project and some other Excel projects. But in any case, The cool thing about this is that it's just learning how to input something into a spreadsheet or a calculator and recognizing that your calculator or your computer understands the order of operations, right? So what it's going to do is it's going to come along and let me just get this. I'm just doing the top line, for example, of this calculation. So just on the top line, it's going to come along, it's going to go, okay, we got parentheses. It sees those parentheses. It goes inside there. And from left to right, it goes, okay, we've got parentheses again. See, so it's your calculator is doing the PEMDAS for you. So it says, okay, now we got parentheses again. So it goes inside there. And inside the parentheses, it has an addition and a division. Which one does it do first? Division first, right. So it starts there. So this is kind of like the number one operation it does, right? Let's say. And so that gets divided to get your big long decimal for your rate, which is great. And then it's still inside the parentheses and it's going to add, right? So that's the second operation. Great, so it does that next, right? So now this parenthesis is taken care of. And so now it looks outside of it. And it goes, okay, you know, left to right, we've got this parenthesis to take care of, right? And inside this parenthesis, there's an exponent. Sorry, I'll do purple. There's like an exponent and there's a subtract. So what does the calculator do first? So exponent or subtract? It does an exponent. So the exponent goes next. And so that's the third calculation. And then there's a subtract inside the parentheses. So that's the fourth operation, the subtract. And then the last thing it does, it goes from left to right. All of this stuff now has been turned into just one number. And then it multiplies by the 1275, right? And so that's the fifth calculation to multiply. So it divides, it adds, it does the exponent, it subtracts, and then it multiplies. Which, by the way, you know, if you had like one of those little cheap calculators, you could do that too. I mean, we could just do each calculation step by step. We could go, you know, let's see, 0.0467 over 12, enter. And we get, that's the first thing, and then we add 1, and then we put that to the power of 180, and then we subtract 1, and then we times by 1275, times by 1275, and we get, 1290.32. Oh, look at that, 1290.32, see what I mean? So you can also do it step by step. That's another way. So there's actually three ways of doing it. You use your big long decimal, you put it divided by 12, you put it as a one line, or you can just do it step by step yourself. Like if you were to calculate this with PEMDAS, what we do, you know, and you just go step by step with order of operations yourself. So lots of ways of doing it. Yep.